Who said no? Oh, okay. Oh, okay. I want to make sure. All right. Okay. So we have to get our heads back in this because it's been a little while since we did this stuff, but we can do it. So take a look at question number 4. We're going to look at it together here. I even put it up here. Wow, look at that. It's like I was planning ahead a little bit. Doesn't happen very often, so we have to embrace it when it does happen, right? Beaker is trying to move a large box across a horizontal floor. He applies a force of 22 newtons down at an angle of 17 degrees from the horizontal. The box does not move. Use F-net equations to determine the magnitude and direction of Fn and Ff. Let's get our head around this. I think we probably made a list before, but I want to make a list again of kind of what to do, how to solve these problems. So forces problems. How to solve them. Do you remember when we were doing projectile motion problems? This was a while before. And you noticed that every single problem was exactly the same? Do you remember that? So it was like you just had to learn the formula and then you could do it and you're done, right? That is not the case in these problems. There's an approach that you want to take every time. But it's not like you're going to use the same formula every time. And I want you to get that in your head because I think that some people were just trying to like apply the same formula every time. It doesn't work that way because every question is a little bit different. What's the first thing that we need to do when we're trying to solve a problem like this? Yeah?
List our givens.
List our givens. All right. So let's do that. Let's go ahead and list out our givens. What? Tell me something I should write down here. I'm going to try and move this down a little bit more. Whoa, that was too far. Come back. All right, givens. You already told me something. I want to share the fun. Yeah. The mass is 6.4 kilograms. How do you know that that's the mass? I couldn't hear what you just said there.
Because it says that it's a 6.4 kilogram box.
Okay, so sometimes it'll say like a 6.4 kilogram box. How do I know that's a mass though? What keys you in to say, excuse me, this is a mass, this isn't a blah, 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 whatever. Yeah, Dakota, what is it?
The units.
The units, right? The units are kilograms. If you see units that are kilograms, you know it's a mass. What's the other thing that sometimes you'll see in a problem like this? Instead of it listed as kilograms, what will it sometimes be listed as? Go ahead.
Like the weight.
The weight. And if you see that, those are the unit. What units are they going to be in then?
Newtons.
Newtons, right? So that's a key to make sure. I'm going to even put that in our list here. When you're writing down your givens, pay attention to the units. The units will tell you everything. Okay? All right, everyone given? I need some more. Share with me the givens that you see. What else do you see? What else do you see? Sean, what do you see?
He uses a force of 22 newtons.
Okay, so 22 newtons. What am I going to label that as?
Force of Beaker.
Force of Beaker.
On rock.
All right. What else? Yes, go ahead.
Does the force of Beaker on box need a vector hat?
Probably it does. And that vector hat indicates that it's got magnitude and direction. And do we know the direction?
Down. Yeah.
Yeah, so maybe let's write that down too, right? So we're going to say at 17 degrees below the horizontal. Good question. What else do we know? Or what are we looking for? There are some of both that are still in here. Doesn't work to just scan the problem for numbers, right? We've written down all the numbers. But there's more to it than that. Zach, what else do you know?
We want to find normal force and like frictional force.
Okay, we want to find the normal force. And we want to find the frictional force. I agree. Anna?
There's no acceleration.
You know that there's no acceleration, right? How do you know that there's no acceleration?
The boxes are moving.
If it's not moving, it can't be accelerating, right? And that's a key thing. That's really important. Okay. Any other givens that you want to include in this list here? Uh-huh.
Velocity is 0.
The velocity is 0, absolutely. Anything else? Okay. So what's our next step going to be then? I've written down my givens. Good for me. Yay, team. Yeah.
Draw a free body diagram.
Absolutely. Let's draw that free body diagram. When you draw a free body diagram, what are you drawing? You're drawing the object and what else? Emma? The forces. What forces?
Acting.
You throw your voice very well. Yeah. The forces that are acting on that one object, right? And that's really important. So it's one object and the forces. I can't write very well today. Let me try that again. Acting on that object, and that's the only one. All right, so let's draw ourselves a free body diagram. So we're trying to move a box. Well, that's pretty easy to draw. I need to know what's acting on the box. What's acting on the box?
The Earth.
John? The Earth. Which way is the Earth pushing or pulling?
Pull.
Pulling which way? Down. Straight down, right? So the force of the Earth on the box, I'm going to write that as Fg because that's the gravitational force pulling down, right? One down, what else you got? What else is pulling or pushing? I'm going to try and share the fun with everybody else. Maya, what you got?
For the force of like the ground or the table or whatever the box is sitting on.
Okay, and which way does that one push?
Up.
Up. And if we're very, very careful, we can write this down, right? It's a horizontal surface. So I'm just going to draw my horizontal surface in just to make my life a little bit easier. And I know that that surface is going to push up because it's what to the surface? Good, it's perpendicular. That's really important. So this is the force of the floor, I guess is what it says here. On the box. That's also known as a what kind of force? A normal force. I'm going to write that as F sub n. Are we doing okay so far? Is this coming back to you? It's been a little while since we've done this, but I'm hoping that it's kind of coming back. All right. I've got two forces acting. Are there any other forces acting? Talk to you guys every day. I want to share the fun. Take a look at the story, friends. What else is acting? Jake, what else you got?
Beaker pushing on the box.
Yeah, where is he pushing?
Like up.
Let's read it really carefully. I mean, you're close. So it says he applies a force of 22 newtons in what direction?
17 degrees.
From the horizontal, right? Up or down? Which way is he pushing?
Up.
Read it. What does it say? What does it say?
Down.
Down. Yes. So we're gonna make this going down. I'm gonna make myself a little horizontal line here. And then I'm gonna draw that force going down like that. So is he really like holding onto the box and pulling on it down from there? Probably not. He's probably standing on the other side and pushing down, right? Does that make sense? But all of the arrows are always going to come from the box. So my arrow is going to go like that. What am I going to label that arrow? The force of Beaker on the box, right? And I'm going to write F sub A because A stands for applied. Yeah. I'm just going to write that as a theta just so I don't forget that it is at an angle. Are there any other forces acting on the box? Ashley?
Force of friction.
How do you know?
It wants us to find the force of friction, so there has to be.
Oh, that's a little snarky way to answer that question, right? It asks for the force of friction, so we got to put it in there. I have another question for you. How else do you know? What if it's...
It's not moving and beaker's pushing, so there has to be something.
Yeah. Right? Does that make sense? I want to make sure that that is okay because the question, like in that one, you were totally right? It asks for the force of friction, so there's got to be something. Although sometimes I've been known to ask the question and the force of friction actually be 0. But in this case, because the box is not moving, right? No velocity, no acceleration, the net force has to be what? 0. So you have to add up all the stuff in the y, and that has to be 0. You have to add up all the stuff in the x, and that has to be what? 0. We've already got one thing going in the x direction, so there's got to be something going the other way. Does that make sense? Because you can't have one number and make it equal 0. Unless the number is 0, and that's not true. All right, so we know there's a force of friction acting. Which way is it going? Yeah, right, that way, right? Friction always acts parallel to a surface. So this is going to be the force of the floor on the box. But this one is F sub F. Is everybody okay with this? This says floor on box. This says floor on box. It's kind of weird. But this is the normal force piece, and this is the friction force piece. Okay. All right, that's a really nice free body diagram, friends. Good work. What's our next step? Let's write down some F-net equations. Yeah. Now, I think, maybe when you said that you had, this is a plural. Did you? Okay. This is something I want to point out because I saw a lot of people when they were doing this on the test especially, that wanted to write down one F-net equation, like one big one with all the forces, which, to be completely honest, is not totally wrong. It's just not very practical. Okay? All of the forces have to add up to 0. That is true. But it's really hard to find two things you don't know with one equation. Are you with me there? In math, you probably talked about that. Two unknowns, one equation, you're stuck. Just start crying and go home, right? That's not helpful. Okay? We need two equations since we have two things we don't know. So we want one in the x and one in the y. Is that okay with everybody? All right. Here we go. I'm excited. F-net equations. I'm going to move this down just a little bit so I've got some more space. Which one do you want to do first? Somebody pick.
Why?
Why? Why should you pick? Because I need somebody, because otherwise we're going to be sitting here forever. You guys are weak. Jeez. Thanks for that. Thank you.
There you go. No,
Did you guys all get that?
Yeah.
Okay, good. I know it wasn't really that funny, but I had to say it anyway. All right. F-net is a Y. Friends, the only reason we write this down is because F-net means two things, and it helps us get to the rest of the equation. What does F-net mean? All right, all the forces. What forces are acting in the Y direction? Raise your hand if you can tell me one. Ooh, pick me, pick me. I want to share the fun with all these people that haven't been talking. Have you told me something already today? I think so. There are like 20 of you that haven't said anything to me today. Come on now. You can all look at this picture and tell me something that's pointing in the, which way is the Y direction? Yeah, it's that one. All right, so now pick one of the arrows that's going in that direction. Raise your hand and tell me what it says. Yeah.
F for Earth on the box.
Boom! The F of the Earth on the box, right? Absolutely. You can write it as F Earth, or I'm just going to be really lazy and write F sub G. Mostly because I'm a lazy bum, okay? But you can write effort, that's totally fine. Sweet, all right, we got one. Is that the only one? No, so raise your hand and tell me another one. Yeah.
Floor on box.
Floor on box, absolutely. Instead of writing floor on box, what am I going to write in my lazy way?
FN.
I am, FN. Because that's the one that's going up, right? Anything else I need to write down here?
0 equals 0.
Equals 0. Are there any other forces that are acting in the y direction?
I feel like,
Yes, Kristen?
Force of beaker on the box in the y direction.
Oh, yeah, if we look at this picture right now, like color coding wise, there are only these two, right? But there's this crazy force that's going in this crazy direction. That makes no sense. What is that? I don't want to have to draw another F-net equation that's in that crazy direction. No, that seems like a lot of work. I want to break this up into two pieces. Is that okay with everybody? Okay, something that's not in the normal direction, I'm going to break it up. So there's going to be one part that's going like this. I'm going to call that F-A-Y. And the other part I might call, I don't know, what do you want to call that one? Oh, you guys are so good. Okay. What?
I'd say FA Mothra, but I guess.
I guess. I mean, you can call it whatever you want as long as it's clear.
Mothra's my favorite.
Are there any other forces going in the up and down direction?
no.
No. So now we're going to take the step Anna wanted to take. F-net, not only does it mean all the forces, but Newton's first and second law says that F-net equals MA, right? Okay, so I'm going to write this down in our list of things to know because I want to make sure that we know this. F-net equation, so you're going to write down all of the forces acting. I'm going to write here parallel and perpendicular to the surface, which might be X and Y, but not always, okay? And MA. So F-net equals all the forces acting, and it equals MA. This is super important. If you don't acknowledge this, then you haven't done good physics. I saw a lot of tests where you had this, like you had all the forces, but then you didn't say this, or if the acceleration is 0, you can just write as 0. That's fine. But you have to say that's true. Otherwise, I can't give you credit for it because you're kind of making an assumption, but you haven't stated it, and we're not cool with that. So we need to say that that's equal to MA. But what's the acceleration in the y direction? 0. It's not flying up in the air. It's accelerating downwards. So that's equal to 0. Are we okay? All right. I'm going to move down and write down this other F-net equation, then we'll come back and actually do some solving. F-net in the x direction. What forces are acting in the x direction? There are still probably 16 people that I haven't talked to yet. Take a look at your picture. Put that hand in the air. Be bold. Even if you know the answer, you've known it since you were born. You're like, I don't want to talk. Come on. Today is your day. Yeah.
Force of floor on box.
Force of floor on the box. The lazy carbling is going to write, instead of force of floor, that's a lot to write. I'm going to write what? FF. Yeah, because it's the frictional force part. Absolutely. What else is acting in the x direction? Anything? Take a look. Hands in the air. I already talked to you. There's still people I haven't talked to. I've already talked to you too. I was like, I don't talk all that often, so I'm going to put my hand. Oh, come on. Oh, come on. Oh, come on. I see 1, 2, 3, 4, 5. Yeah, there's a hand. Yeah.
Force in the x direction.
Absolutely. Good for you. See, look at that. That wasn't that bad, right? Good work. All right, now, are there any other forces acting in the x direction? No. We know, though, that F-net not only equals all the forces, but it also equals MA. So let's write that down. Oh, but by the way, what's the acceleration?
0.
Oh. Well, that's nice. Okay. Life is okay still, yeah? Okay. I need to write something else on my list of things to do, but I don't really know what to do now. What do I do now? What's my next step going to be? Everyone, I was going to call on you, but then you put your hand down. Go ahead. No, you're okay.
Plug in our numbers and solve.
Okay, so eventually we do want to plug in some numbers. I'm not quite ready to plug in numbers yet. There's one more step I want to do first. Yes, Madison?
You need to solve for which force you're looking for,
Uh-huh.
and for the Fy, we're looking for F normal.
Okay.
So we'll rearrange the equation and find that.
So we want to get this one alone.
Yeah.
And on the X, or on the net, in the X direction, we're looking for?
The force of friction.
Okay. Okay. There's one other little step, because I totally agree. This is exactly right. There's one other little thing that I want to make sure that you acknowledge. And that has to do with these little crazy arrowy things on top. What do those arrowy things mean?
Direction.
Direction. Are all of these things in the same direction?
No.
Yes.
Well, no.
They have to act against each other to make
They
zero.
can't be if they add up to 0, can they?
Gravity.
7 plus 3 plus 8 equals 0? Like, that doesn't make sense, right? At least one of them has to be negative. So I would recommend, I'm going to put this in my list of things to do, that before I solve, which is what I really want to get to, right? Before I solve what I really want to do next, step 4 is to assign direction to my forces. And acceleration, if there is an acceleration. Sorry, did you guys catch that? No. Sorry, I was going fast because I was excited. Okay. So here we go. Let's assign directions. What do you want to call FG? Positive or negative?
Negative.
Negative? Is that okay with everybody? If somebody wants to be ornery and make that positive, that's fine, as long as you do everything else backwards now, right? If FG is negative, Fn is going to be
Positive.
positive. And then we have to look at our picture here. Fay is what?
Wait, what? Go down.
Look at the picture. Which way is it going? Down, so that means it's got to be negative. Everybody okay with that?
Yeah.
So I'm going to write that down. I'm going to write that as my next step. It's a big deal. So negative Fg plus Fn minus Fay is equal to 0. I'm going to do the same thing down here. Oh, wait. Which way is FF going? Which way is FA going? Are they going the same direction?
No.
Can't be. They're going to add up to 0, right? That doesn't make sense. One's got to be positive. Which one do you want to be positive?
Fx.
Okay, everybody's like, FAX is positive. Okay, so it's going to be negative FF plus FAX equals 0. Now you're good. Okay? So now we're going to plug in, we're going to solve for our variable, then we're going to plug in numbers. The only other thing that we may need to remind ourselves of is that FG is equal to mg, right? Does that make sense to everybody? Where g is the acceleration due to gravity? I've led you through a lot of this. I want to see if you can step forward now yourself. I think you can. You will need to break your FAX and FAY up into pieces, right? Can I let you try this, or do you need me to hold your hand more? Because I can. You want to give it a shot? No response?
Can you scroll down?
I can scroll down, yes. There you go. All right, I'm going to let you give it a shot. From here, I want to see if you can solve for FF and FN. Okay? I'll give you a few minutes. I'll write some stuff up on the board too, but I want you to see if you can get there. Okay? Talk to your neighbors. Work with them. Go, go, go. So I did write out some work here, so if you want to double check, I've looked around and most of you, it looks like, are on the right track. But your normal force is going to be equal to mg plus Fa sine theta, right? I've had a couple of really good questions about this g. Is it negative 9.8 or is it regular 9.8? So the answer is that you only have to take into account the direction one time. Okay? We took the direction into account here, So the negative in front of the 9.8 is gone. Okay? We've already taken it into account. So when you multiply the mass times g, this is just going to be 9.81. So that's going to be a positive number there. Is that okay? Does that make sense to folks? Okay. So what did we get for the normal force? Did you get something? Everett?
69.2.
69.2, he says. Do you agree with him?
I don't know the units.
Okay. Well, let's figure that out. Let's do sig figs first. How many sig figs do I get? 2. So instead of 69.2, let's just say,
69.
okay. And then what kind of a measurement is this? What are we measuring? Is it a mass? Is it a distance? Is it a force? What is it? It's a force. And forces are measured in newtons. There we go. Okay. How about FF? What did we get for FF? Do you get something, Rosemary? 21 newtons, she says, with confidence. Or she should, because she's right. Yeah. If you want to be really careful, then you'd say negative 21 because it's going backwards. But I wouldn't get really angry. It's like, if you got that, I'd be like, sweet, you got it. That's cool. Okay. Okay. Yes, ma'am.
I am getting a different. Oh wait, never mind. I played it wrong. Okay.
Okay, sweet. All right. So now I need you to tell me what the plan should be. Here are the options. We could go on and work on number 6, which I want to do at some point. Okay? I could also give you time first to work on number 5. If we work on number 6, so let me tell you how things will pan out. If we work on number 6 right now, then I'll give you your test back. So you've got all of that information, and then I'll just give you some time to work. Okay? Or I can give you a little time to work on number 5 now while it's fresh. Then we can work on number 6, then I'll give you a little time, and then I'll give you the test at the very end. So those are our 2 options. Does that make sense? Do you understand? So we're going to vote. So the choices are either work on number 5 or work on number 6. Okay? It's the same stuff, just different order. Raise your hand if you'd like to work on number 5. Like, again, yeah. Raise your hand if you'd like to work on number 6.
Miss Carline, this has 2 number 5s. So.
Oh, yeah.
I bet using your brilliant, gifted mind, you can figure out what happened there, right? I bet so. Okay. I think I saw more hands for the 6. I didn't actually count the numbers for the 5. So I'm going to go ahead and do the number 6. Is that okay? All right. So with your brilliant minds, you can probably find the one that is intended to be number 6. It's the one that's on the back, the first one on the back, with my friend Bunsen. So Bunsen is the one with the green head that looks like a honeydew, which is why his name is Bunsen Honeydew. Okay, and Beaker is the one with the tall, skinny head that is his buddy. All right, let's take a look. It says Bunsen just received new lab equipment, is moving into his lab, applying a force of 24 newtons up a ramp with a 21-degree incline. He's moving a box that weighs 62 newtons at a constant velocity. How large is the kinetic friction force acting on the box? What is the normal force? So in order to approach this problem, we're going to look at our list. Oh, I forgot to write down like the last step, right? Which would be to solve. I'm just going to say solve. All right. First step is what? Let's do it. I want to go through this in a very slow and intentional way because I want to make sure that it makes sense. If you're getting bored going, oh my gosh, you can move ahead, but stay with me because I don't want you to run into a spot and then be like, I don't know what to do. So let's do this together. Here we go. Let's write down some givens. I'm going to reset the speaking hand so anybody can raise their hand now, but just know that I'm going to wait for people again. So what you got for a given? Raise your hand if you got something for me today. Go with me.
His applied force is 24 newtons.
Yeah, so I'm going to write Bunsen here just so I don't get confused. On box, because I'm not so lazy when I start a problem, it's just later on that I get really lazy, right? Is, what was it, 24 newtons?
Yeah.
And it doesn't really say, but it's one of those things that if it doesn't say, then we can probably assume that it's going parallel to the surface. Does that make sense? Okay. If it said that it was not, then we would know. But
But it says he's pushing it up a ramp, so with that
So parallel.
force.
so that would probably be another given, right?
Oh, okay.
Yeah. So maybe we should write like the angle of the ramp, and the angle of the ramp is 21 degrees. Okay. Other givens. What else you got? Go on.
The box was
62 newtons. So what am I going to write that as? 62 newtons equals what? Mass times gravity. Absolutely, we can write it that way. mg, which is also known as the force of gravity, the force of the earth, right? How did you know that that was the force of, excuse me, of gravity and not the mass? Right. It's all about the units. Do you notice that? Pay attention to the units. Okay. What else? What else do we know? There are a couple more pieces of information here. Sean, what you got?
The acceleration is 0 because it's moving at a constant velocity.
Constant velocity, so that means that, do we know how fast he's moving it? Does it matter?
No.
It doesn't. The thing we really care about is that the acceleration is 0. What else do we know? What else are we looking for? Maya?
The normal force. We don't know it.
We don't know it, but we want to know it, right? What else? Is there anything else that we want to know? Yeah, go ahead. Force of friction, absolutely. Kinetic is just in there to make sure that you're paying attention, and because you know that kinetic means what? Motion. It's moving, right? So this is the friction of motion. That's all it is. No problem. All right. Anything else that needs to go on our list of givens? Are we set?
Yeah.
Okay. Just want to make sure I'm not missing something. All right, looking at our list. After we've written down givens, the next thing to do is free body diagram. All right. So, it's important to know that on the last problem, the floor was horizontal, and this one, not so much, right? That's important. Let's pay attention to that. I don't know if you've noticed, but most of the forces problems that we do are either on a horizontal surface or on an angle, right on an incline. Have you noticed this? They're kind of like two different kinds of problems. I'm just saying. Oh, whoa, hi, that's little. Let's make it big again, please. There we go. So here's our box. There's my incline. Talk to me about some forces that you've got here. I want to share the fun. You guys have talked already on this problem. All right, Coda, what you got?
The force of the earth going down.
Force of the earth going down. Straight down, right? Straight down towards the center of the earth. Straight down. The force of the earth. On the box. FG. Fantastic. Question or answer?
Answer?
I'm not going to talk to you right
I
now.
haven't answered this one.
You haven't? Are you sure?
Yeah, I had a question.
Okay, go ahead.
Force of Earth, perpendicular.
Okay, so what I want to do, you are right, but when I draw this free body diagram, I want to just do just the forces acting, then we'll break it up. Is that okay? So hold on to that one. I'll call on you again even to do it in a second. Jake.
The force of the normal force is perpendicular to the horizontal, or the
Perpendicular to the
Platform.
platform, to the ramp, to the surface. Yeah. So we'll say it's going something like, I don't know, like this-ish. Does that look okay? So that's the force of the ramp on the box. Normal means perpendicular. All right, that's 2. Are there any other forces acting?
Yeah.
Probably, since, I mean, you could definitely take the Ashley approach and look at the question, like look at the things that there are question marks next to, right? That might be helpful. You could also just look at your givens list. That'll help you too. Looking for new hands, looking for new friends. What you got? John, go. Bunsen pushing on the box, right? Where does that go? He is, yep, he's pushing it up the ramp. So let's go ahead and just put that one in. Here he is. Up the ramp. So the force of Bunsen on the box. Up the ramp. So FA. There you go. Are there any other forces acting? So mean. I'm so mean. Yeah, Ashley, what's up?
The force of friction
Force of friction. Where's that one going?
down
Why?
because it's like moving against the box so it doesn't slide down.
Yeah. Force of friction always, always, always opposes motion. So if the box is moving up, the friction goes down. If the box is moving down, friction goes up. So if you've ever had something like where you have an object that you're pushing up a ramp and like you push it and then you let it go, you know what I'm talking about? Right? It's like if you push it, you let it go. As it's going up the ramp, the friction pulls down. But as soon as that thing stops and then starts moving the other way, then friction flips. It's like it's smart enough to know. What? That doesn't make sense. It's not like a sentient thing, right? But it's always opposing motion. That's important to know. That's dark, man.
That'd be scary. Like if friction turned against you.
I guess.
You couldn't walk anymore.
Sounds like a really bad movie.
True. Friction is just like
It's going to reveal
no, a little too much friction.
All right.
Friction.
Are there any other forces acting? No, let's move on. Where is that? She thinking? Oh my gosh. Everett?
Yeah, just kidding. Force of Earth perpendicular to the ramp.
Okay. So when we start to play with our F-net equations, right? We want 2 F-net equations, not 7, not 3. We want 2. And right now I've got things in all different directions. So he's like, I want to do this. I want to break it up into pieces. These guys are all perpendicular to each other, these 3. So let's not break them up. Let's break this one, the weirdo, right? Get rid of the weird one. I mean, that sounds really dark and mean, and I don't mean that like about people. I really want to make that clear that I don't want to be like sounding like a jerk. But in this case, if you're trying to have things all perpendicular to each other, you need to get rid of that force that's not perpendicular. That's all I'm saying. I realized I sounded kind of cruel there, and I didn't mean to. So I apologize if anybody took that wrong. I didn't mean for it to happen.
You could also say that when people have multiple parts, and that could be really deep and philosophical.
All these deep philosophical options. Now, one thing to point out, friends, and this is really important. I didn't notice a lot of this, but sometimes I just go fast when I'm grading, so I want to make sure that you catch this. This one, the big one, the one you're breaking up into pieces, must be the hypotenuse of the triangle. This one has to be the hypotenuse. These guys are going to be shorter. They're legs. Think about what's going on, and it shouldn't be too hard to do. So this is going to be FG parallel. We okay? Okay. All right. We drew a free body diagram. Good for us. Step 3 is F-net equations. Parallel and perpendicular to the surface. All the forces acting, and it's equal to MA. Here we go. Oops. Parallel, perpendicular first. Which one are you going to do first? Heard 2 things at the same time.
Why? Yes, why?
But why isn't a choice? Perpendicular first.
Yeah.
The loud people say. F-net.
Because I already have written down.
Oh, and he's lazy. I can respect that. F net perpendicular. What's acting perpendicular to the surface? Take a look. You guys can look at this. It's all color-coded too. Have you noticed that? Just saying. Like you can find these things. Maybe what you got? FN. What else is acting perpendicular to the surface? Right, it's labeled perpendicular, right? It's gotta be. I mean, come on. That's not hard. I'm not trying to like sell you short, but yeah, absolutely. Perpendicular. Are there any other things acting perpendicular to the surface? No. F net equals all the forces. That also equals what?
MA.
Yes, MA. It's true. But A happens to be what?
0.
We have that in our list of givens, so that's going to be 0. That's nice. All right. And then we've got F net parallel. Save the best one for last, right? F net parallel. What you got acting parallel? Raise your hand if you can tell me. Ooh, pick me, Miss Carveling. I want to tell you. Mitch, what you got?
Force of friction.
Force of friction. All right. Maggie, what else you got?
What is the applied force?
Applied force, awesome. And Carrie Ann. What else? Oh, sorry.
Sorry.
Not trying to catch up guard.
I was like going through the other one. Like I'm a step ahead. Okay. FP parallel.
Fantastic. Those things have to add up to what? 0 because it's not what? Not what? It's true. All right. Then it's not a very interesting problem. So then we probably wouldn't do it. And then the question doesn't make any sense. All right. Step 4 is important. Step 4 is really important. Don't skip step 4. Let's assign directions. This is important. Fn, is that one going to be positive or negative?
Positive.
Okay. Does it really matter?
No.
No, as long as you're acknowledging that Fn and FG perpendicular must be what?
Opposite.
Yeah. So if Fn is positive, then FG perpendicular needs to be negative. Okay? What about FF? Is that one positive or negative? Negative. They decided. It's negative. Okay. Oops. I wrote G. I don't know why. FF. If FF is negative, what about FA? Positive. And does everybody see how you figure this out? Like you really are literally just looking at the picture. If one arrow points this way and another one points this way, they have to be in opposite directions. Does that make sense? Like you're just literally looking at the picture. So if you start off from a good spot, life is good the whole way through. It's all there. Talk to me about FG parallel. FG parallel, is that positive or negative? Negative, because it's the same direction as FF, right? So it's going to be minus FG parallel equals 0. So from here now, friends, all we need to do is break this into its pieces with sines and cosines. You can identify what you need to solve for and do it. I'm going to let you go again. Go ahead and give it a shot. How are we doing? Are we doing okay? Are we ready to compare some answers? FN, what did we get for FN?
57.
58? I think that's what I got too.
58, not 7.
Changing your story. And what about for FF?
1.
Negative 2 or 1.8, something like that. I had 1.8. I think it just kind of depends on how you round. But I did put the negative in there because it is going down. So what I'm hopeful of is that This was either very helpful for you because, man, you didn't understand this before, like, wow, that was da-da-da. Or if you did get it before, at least hopefully it was a good refresher. Because this stuff isn't going to go away, friends. I mean, we have that final coming up at the end of the year anyway, right? So, like, another little moment of thinking this through is always a good thing, okay? So I'm hopeful that this was useful for you. What I'm going to do now is hand back your tests. I want to go through the test, through the whole thing. So it's going to have some momentum stuff on it, and it's going to have some other stuff things too. And I want to go through all of it because I want to make sure that it makes sense. After that, I will give you some time to just work. You can either work on corrections to this problem set. You could work on corrections to other things. And if you're done and ready to move on, then I can tell you what the first section is and the next unit to read if you're ready for that, okay? So does that sound okay, like an okay deal? Okay. So I'm going to hand back tests. While I'm doing that, there's a bunch of stuff that needs to be handed back, like, that's graded, so we'll pull that out too. John, yeah, what's up? You look like you were raising your hand. Were you, or was I just dreaming?
I was raising.
But it's okay? Okay. I just want to make sure I wasn't going crazy. Okay. All right.